Find the area of the polygon ABCD in acres. In this problem, points A, B, C, and D are shown, and the bearings and the lengths of the connecting courses are provided in the data table. To solve this problem, we'll use the coordinate method for finding areas, where the area equals 1/2 times the absolute value of the sum of the product of the y-coordinate of a point times the difference between the x-coordinate of the preceding point and the x-coordinate of the subsequent point for all n points. Therefore, we'll have to solve for the x and y coordinates of points A, B, C, and D using the given data. Since no coordinates are given for any of the points, we'll arbitrarily set point A at the origin of an xy coordinate system, where ax equals 0 feet and ay equals 0 feet. Next, we'll use the bearings and length values given for the 4 courses to determine the x and y coordinates for points B, C, and D. From trigonometry, we can equate the x value of point B to the x value of point A plus the length of line segment AB times the sine of the bearing of course AB. If we plug in the x-coordinate of point A, length AB, and the bearing of course AB, the x-coordinate of B equals 247.45 feet. We can find the y-coordinate of point B by adding the y-coordinate of point A to the length of line segment AB times the cosine of the bearing of course AB, which equals 40.30 feet. The coordinates of points C and D are calculated the same way as coordinate B was. We'll plug in the x and y coordinate values from the previous point on the traverse, plus or minus the length between that point and the previous point, times the sine or cosine of the bearing of the course from the preceding point to that point. After plugging in the appropriate coordinate values, lengths, and bearings, the coordinates of points C and point D are determined. Lastly, we'll confirm the traverse closes by calculating the coordinates of point A, using the coordinates of point D, the length of DA, and the bearing of course DA. We calculate point A is indeed located at the origin, 0, 0. This means the traverse closes and doesn't need to be corrected. Next, we'll set up a table to summarize the x and y coordinate values of points A, B, C, and D. And we recall our equation for the area only involves these x and y coordinate values. Next, we'll add a column to the table for the variable I. Variable I corresponds to the iteration in the summation. To avoid confusion, the term y sub I refers to the y-coordinate of the point whose value is I. For example, if I equals 2, then y sub 2 equals 40.30 feet, as shown in the data table. As a second example, if I equals 1, then x sub I minus 1 equals x sub 0. But there are no points whose I value equals 0. In this case, we'll loop back around and use the coordinates for I equals 4, which are the coordinates for point D. A similar situation occurs for x sub I plus 1 when I equals 4. To avoid this confusion, we'll add a row for I equals 0 and for row I equals 5, which are just copies of the coordinates data for rows I equals 4 and I equals 1, respectively. Returning to our equation for area, there are 4 vertices to the closed traverse, so we'll assign the variable n to equal 4. Next, we'll write out the summation equation for values of I ranging from 1 to 4. Then we'll plug in the appropriate values for x and the appropriate values for y. And the area of ABCD equals 29,334 feet squared. Since the problem asks to find the area in acres, we'll divide this quantity by 43,560 square feet per acre, and the final area equals 0.673 acres. When reviewing the possible solutions, the answer is B.